Good morning, everyone. Today I am going to present the topic is combinational circuit. The combinational circuits are an important concept in digital electronics, and it is the basic building blocks of an digital electronics. Digital electronics having two circuits. One is combinational circuit and another one is sequential circuit. So today I am going to present the topic is combinational circuit. So in this presentation I will explain the meaning, characteristics, types, applications and advantages of combinational circuit. And now we are going to the introduction of the combinational circuit. So what is meant by combinational circuit? First, let us understand what is combinational circuit is. A combinational circuit is a digital circuit in which the output depends only on the present input values. This means if we change the input, the output changes immediately. Unlike sequential circuits, combinational circuits do not have memory, so they do not store previous values. So the combinational circuits depends only on the present input value. It has no memory or it has no any feedback path to store the past data histories. Okay. Now we are seeing about characteristics of the combinational circuit. Okay. The first characteristics is that output depends only on the current input. Already we have to know the combinational circuit have no memory element. It have no any feedback path. Second characteristics of combinational circuit is no memory element. And third, the circuit works very fast because there is no delay due to memory storage. It has no memory element, so there is no need to analyze the history of data. So it works very fast. Finally, they are building using logic gates. They are building using logic gates of combinational circuits. What are the logic gates to build the combinational circuits? Such as AND gate, OR gate, NOT gate, NAND gate, NOR gate and XOR. Now, logic gates are the building blocks of combinational circuits. The AND gate produces output only. The AND gate produces output only when all inputs are 1. When all inputs are 1, then only AND gate produces an output. Then the OR gate gives output if any one input is 1. The OR gate gives output if any one input is 1. Then only it gives an output. The NOT gate inverts the input values. If I give the input is 1, then the output value becomes 0. So the NOT gate inverts the input value. The XOR gate is mainly used in binary addition operations like adders. Then there are different types of combinational circuits. There are different types of combinational circuits. For examples, A half adder is used to add two binary digits. Half adder is used to adding the two binary digits, and the full adder can add 3 bits including carry input, and multiplexer selects one input from many inputs. The decoder converts binary information into output lines, while an encoder converts input signals into coded output. So there are 5 types of combinational circuits are there. One is half adder, full adder, and then multiplexer, encoder, decoder. Multiplexer having 2 types, that is meant by multiplexer and demultiplexer. The both are same device but two operations, multiplexer and demultiplexer. Multiplexer is used to select one input from many, and demultiplexer one output from many inputs. Next, we are going to the difference between combinational versus sequential circuit. Now, let us compare combinational and sequential circuits. Combinational circuits do not have memory and depend only on present inputs, but sequential quite opposite. Sequential circuits having memory and depend on both present and previous input. For example, sequential circuits are flip-flops and counters. Flip-flops and counters are nothing but a memory element. It has storing one bit of data. Both are storing one bit of data. Counters are simply grouping of a flip-flops. So flip-flop and counters are both are act as a memory element. Flip-flops can store one bit data. Counters nothing but groups of flip-flops. So combinational circuits only depend on the present input and then produce an output, but sequential circuit having memory, the output depends on both present input and previous inputs. Now see the applications of combinational circuits. Combinational circuits have many real life applications. They are used in computers, calculators, digital communication systems, traffic light controllers, and arithmetic operations in processors. These circuits help electronic systems perform calculations and decision making. Then we see the advantages of combinational circuits. They are simple design, so it is easy to design the combinational circuits, and its fast operations, less complexity, and then high reliability. Because of these benefits, they are widely used in digital electronic devices. And then last, I conclude combinational circuits are one of the basic and important concepts in digital electronics because they produce output based on present input values and are widely used in many electronic systems. Thank you.